Okay, so this problem deals with trigonometric identities, okay? And so trigonometric identities are not overly difficult. It's just getting used to how the formulas are set up, okay? So before I get into that, first thing that we really want to do is finalize out the triangle over here. Okay, we want to make sure that that is that we have all the parts labeled. So what I'm noticing is here is I've got a big B, right? Capital B. Opposite of a capital B is going to be a lowercase b. Opposite of lowercase a is going to be a capital A, and opposite of lowercase c is going to be a capital C. Okay? So I now have all the parts of this triangle labeled except one, and that's going to be this angle right here. Now luckily for us, we know that the sum of the interior angles, okay, the sum of the interior angles of a triangle equal 180 degrees. Okay, so we know that. The sum of the interior angles of a triangle equal 180 degrees. Well, what's great is that I also know that this is 90 degrees because it's got the little square. So 90 plus 50 is 140, and I know I'm going to have to add an additional 40 degrees onto that to get to 180. So now I have all of the angles in this triangle. Notice I haven't even hit the trigonometric identities yet. Simply just working with filling in the triangle. All right, with the appropriate letters and terms and measurements. So from this point, we want to just make a few quick identifications. C is my hypotenuse, okay? And I always want to remember, C is always going to be a hypotenuse in a right triangle, okay? That is something to always remember. Now, let's go to the trigonometric identities, where we want to remember this phrase, the SOHCAHTOA, and I suck it to them, but SOHCAHTOA, where SOH, S-O-H, is sine of a degree equals the opposite side to that degree. Oops, sorry, made that a little too long. Opposite side to the degree over the hypotenuse of the triangle. CA. So now we're going to look at the next one, which is the CAH, which is the cosine of a degree is equal to the adjacent side to that degree over the hypotenuse. And then TOA, which is tangent of a degree, is equal to the opposite side to that degree over the adjacent side to that degree. Okay, so what does this all mean in terms of the triangle? Well, if A is what I'm looking at, right, as my angle, what I can see here is that this is the opposite for angle A, whereas this is the adjacent for angle A. Okay, so this side right here is the adjacent side to angle A. So let me do this actually using a bit of color coding, so that way you can see it a little bit better. So here's my 90 degree, and here's angle A. You ready? So here is, let me get some different colors going. Here is my adjacent side. So there's my adjacent side. And here is my opposite side. So there is my opposite side. Okay? Now hypotenuse stays the same because it never changes. So there's your hypotenuse, and there's your hypotenuse. And we have this for A, right? What if I change this to B? And so I change this over to sine of B. So sine of B is equal to, again, opposite over hypotenuse. Cosine B is equal to the adjacent over the hypotenuse. Now check this out. So hypotenuse is still blue in both cases here, but the opposite side is now red versus adjacent, right? So it's different. And the adjacent side is now green. So you notice it's all relative. What angle are you working with, and how does that relate? So going back to this triangle, and I know this is getting a little long, but I want to really solidify these trigonometric identities and these ideas, okay? So let's just zoom this out a tad, bring this up. So solving a right triangle. Basically, I need to find A and I need to find C. A is opposite of angle A, so if I have sine of angle A equals the opposite over the hypotenuse. The biggest issue I'm going to run into here is that I have sine of 50 degrees equals A over C, and I don't know what A and C are, so I've got two unknowns and one equation. So I need to get a different equation. So I'm going to try sine of angle B is also the opposite over the hypotenuse. But what I can see here is that the sine of B is really the sine of 40, which is the opposite, so 20 over the hypotenuse C. Now I have something to work with here. So let's bring this up. Because C and sine of 40 sit on reciprocated sides of a fraction, okay, opposite sides of the fraction, one's in the numerator, one's in the denominator, all we're going to do is we're just going to switch those, okay? So we're just going to have them trade places. And so we're going to get C equals 20 over sine of 40. Now there's a reason for that. I'm not going to go into it right now. And what you can do at this point is grab your calculator and click 40 and take the sine of it. Okay, so we're going to go sine of 40 is 0.745. So this is now equal to 20 over 0.745, and 20 divided by 0.745 is 26.8. Okay, and you can run these numbers. So that is my hypotenuse. So now check this out. Because I now know my hypotenuse, here I can plug that in to C right there. So now I've got sine of 50 degrees equals A over 26.8. So now all I do is I do a quick cross multiplication, and I've got sine of 50 degrees, which is a number, times 26.8. And that's going to equal A. So if I take the sine of 50, I get negative 0.26 times 26.8 is equal to negative 7.03. Okay? And so now you found out what A is. On a standpoint of logic, this number that number doesn't make sense. So I'm wondering if I missed a number somewhere, or I typed something in a little incorrectly. But in any case, this is the process that you use to solve it.